Yeah, I was a researcher. Maybe I'm still a researcher, but I was doing research at CERN in fundamental physics, high energy physics, particle physics in Swedish. In 1990, I really loved that. And so it was a great job when one day a friend of mine mentioned, "Hey, Chris, I found a new job for you." I said, "No, I'm doing research in physics. What can be more fun?" "Well, they're looking for astronauts," he said. I thought he was joking, but the next day he gave me this ad. He cut out the newspaper. You know, this was well before the internet time, although the internet was or the web was invented at CERN in those days when I was there. But no, this was a normal job ad in the newspaper, Dagens Nyheter. The European Space Agency is looking for up to 10 astronauts. Wow. It was a chance to go to space, something which I actually had in my mind for many years at that time. But I didn't even know that there were astronauts in Europe before I saw this. So I decided, okay, I will work hard here for a good application. Was apparently good enough. I was invited for interviews and tests, medical tests, psychological tests, more interviews. Actually, the process lasted for 2 years. You know, that was in June 1990. I got a telephone call the 15th of May, I still remember the day. 92, I said, okay, you have become one of Europe's only 6 new astronauts. And then thing was to move fast. Already 2 weeks later, 1st of June, they wanted me to start working at Cologne, at the European Astronaut Center in Cologne, Germany. And the first thing almost I was told was, hey, by the way, you probably have to go to Russia soon. But if you know your history well, that was during the time when the Soviet Union kind of collapsed and Russia came up and inherited the Soviet Union space program. And the West wanted to help Russia, and it was also kind of opportunity and not so expensive to work with them. We hoped they would become a democracy. We know that that failed now. But sure enough, a year later, I was sent to Russia. And I was to train to fly with that capsule, kind of capsule Soyuz, to the then Russian space station Mir. And it was a lot of training things like here. Learn how to jump out of the space capsule if it lands in the water with your spacesuit on. Those things were not the really hard ones. That was the language. Everything was in Russian. And we had no interpreters, no material which was translated. And I didn't know a word Russian when I was told to go to Russia. Well, we did get a little bit training before, but not enough. But worked hard, and eventually I learned to speak Russian. Today I speak decent Russian. You know, it's always nice when you work hard, you overcome the difficulties, and eventually it works. What was less fun was that I was not the guy who was allowed to fly with that to the space station. I was only the backup at then. And instead I was soon sent to United States, to Texas, to Houston, where NASA has its astronaut center, Johnson Space Center. And I became a member in the largest astronaut class NASA ever have had, and I can promise you ever will have also. Is this a pointer? Well. We were 44, out of 9 were foreigners. But unfortunately, as you can see, a very long line. And top left there, you see me, a younger version of me, at the end of the line. So it was still a little bit wait for me to go to space. But eventually, in December 2006, I finally boarded the space shuttle Discovery. And I hope we get some sound out of this because it's more fun. 14 and a half years after I started training as an astronaut, I was finally on my way to space. And the feeling when the rocket engine starts and the boosters ignites and you know you go somewhere, hopefully all the way out to space. I think you can increase the sound for a few seconds. You can. Yeah, it is shaky. Okay, I'm going to decrease both psychologically and physically, but I was mainly just laughing there in my spacesuit, finally on my way to space. It's huge things, about 2,000 tons, and you can say it's around 50 million horsepower, which you can point out when someone brags about this new car with a few hundred horsepower. Unfortunately, though, this space shuttle was a fabulous vehicle. You know, I mean, it was mainly reusable. However, it was too much work between flights, so it never became cheap, although it was reusable, and it was not robust. It had 2 fatal catastrophes on 135 launches. So once one had decided to kind of, or once the International Space Station was fully assembled, then one retired the space shuttle in 2011. And our job for this mission was actually to continue building the space station. So 2 days after launch, we docked with the space station, which at that time was pretty much exactly halfway built, and had 3 people in the crew on the station. And already the following day after docking, during the first spacewalk, wonderful feeling, get outside there floating. We put the new piece, which you could see there, on the space station we had brought up with the shuttle and then put on place with the robotic arms. We used these kind of battery-driven bolt drivers to work with. Following day, we were going to retract some solar arrays, which later had to be moved, with the help of commanders from the inside. Well, that was the plan. As you can see, it didn't want to fold up together like a map, always difficult. So this became a problem which the ground control, mission control center had to try to figure out how to solve. While they were thinking down there, we were continuing working up there with what we had trained and planned for several years now. Here you can see pictures from this second spacewalk. Well, it's always nice to tell your friends and acquaintances what you're doing. And here was the live connection with Stockholm. And I did a little frisbee trick, which unfortunately I didn't want to acknowledge as a world record, when I thought it was cheating, doing it in weightlessness. Instead, we got the order from ground that, hey guys, you better go out to another spacewalk and fix these solar arrays. And that was a challenge. We had not trained for this. No one really knew what the problem was when we started this spacewalk. But with the help of these really smart girls and guys who were working down in the Mission Control Center, we could all together find the solutions. We could retract the solar array. And we were happy when we left the space station. Here you can see, by the way, it's empty there in the payload bay of the shuttle. We had brought with us that part to the space station now. We still had a few things to do. A few experiments which were deployed from the shuttle. This one was going to study the remainder of gases, or rather just single atoms, which are still there on several hundred kilometers altitude above Earth. And 13 days after we left Florida, we're back there. Our commander did a perfect touchdown in the sunset 2 days before Christmas Eve, which was good he could do, because the shuttle, when it came in for landing, it was like a glider aircraft, and very clumsy as such. So you didn't have another chance to go around if you came in wrong. But at least that part always worked well for the shuttle. And indeed, this whole mission was a fabulous mission. This picture was taken by our commander from the shuttle during the first spacewalk, and it later ended up at the website for travels. And someone gave it the kind of title, Travel Picture of the Year 2006. So that's not my kind of invention there, but I can just say I agree. Someone thought it was just too good to be true, and some comments said, okay, this must be photoshopping. But I can tell you, no. It's me there to the right, to the back, so I know, to the camera, so I know this is true. And what you see below us there is New Zealand, by the way, the South Island down there. And we call it spacewalk. Well, we're not walking. We're climbing, or like in the mountains. And therefore, we also have safety tethers, as you can see there. It's not that if you would lose grip, you would not fall down, but you would just glide away from the space station, and you have no way to come back. So I also want to point out that the astronauts are really just the tip of the iceberg. And it's really unfair that almost all the kind of good words that goes to the astronauts, and they get all the attention. Because there are thousands of people involved in any space mission. And many of them working in the Mission Control Center, which typically looks like this one here. And they should have just as much credit. Now, though, the really funny thing with this picture here is rather the two flags there to the left side. The kind of leaders for the spacewalks was in NASA lingo called extravehicular activities. Well, they started like Sweden, so they brought a flag down there, which is much bigger than the American flag, right? I got the second mission to space, and here I'm on my way with my second crew to the launch pad here. And like my first flight, we were 7 people in the space shuttle. The others were Americans, but it was a different crew this time. And we're coming here out of the crew quarters, where we have been living in quarantine for the last 1 week plus, to not have some bugs and stuff with us up to the space station. And here's a picture from that launch. It was midnight, exactly local time. So down to the right where the kind of track starts, that was the 28th of August 2009. And several minutes later, when someone can stop taking a photo, it's the 29th of August. This picture here shows you quite nicely the dynamics with going to space. It's not that we're going up there and crashing down, no. But in order to stay in orbit, you need a very high speed, around almost 28,000 kilometers per second, almost 28,000 kilometers per hour, which is almost 8 kilometers per second. And to get that speed, you cannot have air resistance. You have to be above the atmosphere, and that's why we go high up. We say the space starts at 100 kilometers altitude. Well, there's still a little bit too much remainers of atmosphere there, so you want to go to several hundred kilometers altitude. And then you can really start to accelerate and get the speed. And it takes some time, and we follow the Earth, and Earth is round, right? That's what you see there, basically. Well, this mission also went to the International Space Station, which at the time then was almost fully assembled. And this is how it looked when I left it from the second and probably last time I saw it with my own eyes. It was a really fabulous kind of feeling to be part of this. I was so glad and proud to be able to build this thing here. This is the step towards future space endeavor. But when I was there, I had already a long time before that, I told my bosses that, okay, this is it for you. Sweden didn't pay much at the time. So I know I will not come back, but it's really an amazing thing which has been put together in space like a huge Lego. Piece by piece. Well, the first piece was brought up already in 1998, late 98, and then 2 years later, 1st November 2000, it was big enough to have a permanent crew. And it has had that ever since. So for 23 and a half years, that's probably longer than most of you have lived, there have been people living continuously on this space station. Typically, the people who are crewed there, they stay there for half a year at a time. And the reason it's half a year is that they have always a vehicle with them, a capsule, which they can jump into, come back. And these vehicles are certified for 6 months in space, so you don't want to waste them. In the beginning, we were normal 3 people. Now it's normal 7 people, and they have 1 Russian and 1 American rescue vehicle. The American can take 4 people. So that's big. That's a little bit over 100 meters wide and about 80 meters long. And we have built this space station because we want to learn how it is to build and live in space, prepare for future exploration, but it also offers unique possibilities for science. All these views there, both upwards and downwards, but in particular it's the weightlessness, the long-term weightlessness, which offers unique possibilities for research, which you just cannot do here on ground. So it's all from physics to biology to medicine. Just to give an example, you see the 2 lights pictures there to the left. Everyone knows how a candle looks here on Earth. looks like that because warm air is lighter than cold air, so the air goes upwards when it burns. And you have to get new air coming in on the sides, and you get an air circulation and convection. And it get fresh oxygen. Well, in weightlessness, it doesn't matter that the warm air is light. It doesn't go in a particular direction anyhow. So it just diffuses out. You don't get as much oxygen coming in, so it can also get a different color. And biology, we study everything from simple cells, actually. Even the gene is kind of how they express themselves is different in microgravity. We don't really understand why, but that we have noticed. And we study up to animals, and we study humans. Astronauts are really guinea pigs up there. So much happens to our human bodies in weightlessness in particular. Most of them negative things. I'm probably not healthy to go a long time to space, but it's pretty fun. So, you know, it's fun. So, I mean, your muscles, your bones deteriorate, get weaker. Your immune system gets weakened. People come back with vision problem, deteriorated vision. We don't really understand why. And all these things we need to learn and try to find countermeasures. And therefore, there's a lot of experiments going. We even study how people perceive things by taking EEGs in space. That's also different. But it's not only that we need to find countermeasures. Also here we learn new things of our human bodies because we study the bodies in new conditions, and this gives new information which we also can use later to help people with medical problems on ground. Yeah, I also want to show another picture here which shows you something happens to your body in space. Me there to the left, just before the launch of my second flight, I started to get a little bit older. I started to get wrinkles in my eyes, in my face. And then a few days later, I'm in space, and you see I look much younger and beautiful. The wrinkles gone away. Well, the reason for this is that here on Earth, the kind of weight pulls down your body fluids in the legs. But that doesn't happen in weightlessness. So body fluid shift happens. It goes up towards your head. So you get more tiny legs and you get more fluffy in your face. And although if it looks nice, it doesn't feel nice. It can feel like you have some cold or something like that. But anyhow, that goes away as soon as you get back and you look old again. So, a few things about living in space, which is very different. And also, we kind of important to conserve resources because after all, it's kind of expensive to launch things to space. And but you know, if you just have energy, you can conserve and recycle a lot. And I always like to brag about that on the space station. We have 100% green energy, 100% green electricity. It's all from the big solar arrays. Now, living in space is particularly kind of due to the weightlessness makes it so different. Now, I should try to tell you what weightlessness really is, because that's often misunderstood. Weightlessness is not absence of gravity, not absence of the gravitational force. If there was no gravitational force, the space station would not go in an orbit around Earth, it would just go away, right? Now it's when nothing kind of counteracts the gravitational force, then you get weightlessness. It's the counteract that gives you weight. So, you want to be weightless for a while? Do it like that, you know. You're a little jump there. You're weightlessness for tenths of a second. But there's no use if you jump out on an airplane because you will very soon get a speed which is so high that the air resistance exactly balance out the G-force from the Earth. So then you're not in weightlessness anymore. But not even my students at Royal Institute of Technology in the fourth grade always, fourth year, they always give me the right answer when I ask them about weightlessness. So. But think about that. So one problem with the weightlessness is that water doesn't fall down. So you don't have a shower up there. So it's a cheap hotel. But what you do, well, you can take a little towel, put some water on it, and then you clean yourself. That's how you do it. And if you're on a shuttle, had many of these towels. When you brush your teeth, you can spit out the Bruce spray there and throw that away. Another thing, as I mentioned, people on the space station, they live there for half a year. You may need to cut your hair. Well, then you have to think about that the hair won't fall down on the floor. It will just, float out in the cabin. So what do you do then? Here you see Tim and Nicole cutting the hair on Roman, and they're connected a hose from vacuum cleaner to the scissors to kind of collect the things. So all these things makes it kind of complicated to live in weightlessness, but it's fun also. Now, exercise is always important, and I hope you do your, you go do your exercise regularly. But it's really crucial to do it regularly in weightlessness, because your muscles and your bones, they don't get any normal stress, which you get here. So they weaken very quickly. And that's not a problem in space, because, it happens because you don't need it there. But you will be a wreck if you don't keep in shape while you're up there when you get back. So on their daily schedule, working schedule, the astronauts up there, they have twice a day physical exercise. And there are various machines for that, like a treadmill, but you have to connect the harness so you don't float away when you run. That up to the right there, that's for strength training. It's no use to use weights and weightlessness for that. So this machine kind of gives the same resistance as you would normally get from lifting weights. And after that got to the station, after a while, people come back in better shape, actually. The bones are somewhat better. Down right, there you see me at the little ergometer, which we had on the shuttle. Even there, although it was only 2 weeks, we got opportunities to work out. But we didn't have it on the schedule twice every day. Well, the food, here you can see a little bit how we eat. And there's no particular food. It is the usual stuff: meat, fish, pasta, etc., vegetables. But you cannot prepare it. You cannot boil or fry food. You cannot put on a plate. It has to be conserved in a way that it can last for many months, maybe up to a year, without having to be in the fridge, because we don't have a fridge for food to kind of save some electricity. So it's kind of, some food is vacuum dried, like this one there, and then you can push some water in there, which can be somewhat warm. You get somewhat warm, you let it absorb for some minutes, and then you cut open and eat straight out it. So it's a bit special up there when it comes to eating. And I thought it was boring after 2 weeks, just managing what they think after 6 months. But you can, of course, play with your food in different ways. You're not supposed to do that, but many of you maybe have seen this. If you want to drink something, you fill a bag with water from a dispenser, and that in that bag can be some powder, which gives it some taste. But this is an alternative way to give it space. And if you like physics, you can see some funny physics phenomena here also. These are normally has the shape of cars, but I had a special edition with me. I want to become a submarine. And here now I simulate a black hole taking a water plant. Well, yeah, if you're from Sweden and you have some ages back, you recognize that. But as I said, we want to try to, reuse the resources smart up there. So what we are doing, we have developed a life support system, which is kind of trying to be sustainable and recircle as much as possible. And this is also for future development for the future. The further you go away, the harder it will be to send things from Earth. So I'm not going to go to detail there, but basically, you eat and you drink, and the water comes out. The water comes out from sweating and breathing, and also from the urines. Up to 95% of that can be reused. The water which goes up from your back, so it's the shit, we are not able today to reuse, so that we have to throw away. The carbon dioxide which we exhale, we breathe in oxygen, we exhale carbon dioxide. 40% of that we can also reuse with the chemical ways. Actually, you get the carbon dioxide, you got some water, you can get methane and oxygen, and the methane you throw away. But in the future, you can use that for rocket fuels if you do this on the Moon or Mars, for example. But you have to bring your hydrogen somehow for that. Now, so this is pretty advanced system on the ISS. And sometimes it breaks, and that's a kind of problem. But what you see here is one of my classmates, actually, Jeff Millions. He had to repair the urine recovery system. Well, he doesn't look so unhappy there anyhow. But now, if this breaks on ISS, it's not a really big problem. I mean, we can get spare parts up fairly soon. Or if it's really bad, yeah, but you jump into your kind of rescue capsule and you get back. However, in the future, when we go into Mars, these things has to work or be able to be repairable. With today's rocket technology, it will take at least a year and a half way and back. And once you kind of got an acceleration and started to fly towards Mars, you cannot come back until you've gone around Mars and come back. So it's really critical that these things works. And to me, this is one of the bottlenecks still before we can send humans to Mars. But we are then doing some research to kind of see how can we do better. And one way to do better is that instead of bringing every single spare part, well, you bring just the material and make the spare parts. And if you can make it through modern methods, 3D printing or additive manufacturing, it's also called, that's better. That's difficult to do in weightlessness, because normally you do it using the help of the gravity, but this is one of many things we are kind of working on. In addition to the weightlessness, just floating around, really fun, the other really exceptional thing being in space is the views on Earth. Not very far away. The space station's around 400 kilometers altitude. I was at 360. But still the views are amazing. And it takes only 90 minutes to make one orbit around Earth. So you always see new things. And you made one orbit, Earth itself has turned a bit. And people take photos, amazing number of photos. And NASA actually put all the photos astronauts take on Earth on a website, which is open. You just go look for it, and you can put in Lund or wherever you're living, and you get many hits. And now, another thing we should see up there is how thin and fragile the atmosphere looks like. So this nice photo was taken from the shuttle. You can see the rudder of the shuttle there. Up is the Earth, and down is space. And that thin colored line, that's our whole atmosphere, about 100 kilometers thick. And only 5%, 5 kilometers closest to Earth, that's where we have enough oxygen for us humans to live. Most animals also, by the way, without the spacesuit or a spacecraft. And we have to be careful about this. We were very careful about our atmosphere on the space station or the shuttle. We wouldn't have much time if things were going wrong with it there. We have more time here on Earth, but we know we are kind of fiddling a bit with this atmosphere, and we need to be very careful. And we need to work and solve this together. You don't see borders from space, by the way. The other thing which really makes you kind of sentiment, really get nice feelings you see from space, is your home, your own home. That's where I live, in Stockholm. This beautiful picture of Scandinavia, I cannot brag, I took it myself. It was taken a few years later from the International Space Station, another of my classmates, Scott Kelly. And he was lucky. I did see Stockholm from space, but not as good as this one. I mean, he was lucky because no cloud over all of Scandinavia, and in addition, he got the aurora there in the background. But after some space adventures, I'm now back in Stockholm, where I work as a professor in space travel, or astronautics. And I work with mainly human spaceflight still, but also a lot of other things. And what I want to tell you now, that all of course, for me and many others, the human spaceflights are most inspiring and interesting. But what space is giving us is really an enormous infrastructure for a much better life here on Earth. And we are using it daily, all the time. Space services is becoming a natural part of everything we're doing on Earth today. And everyone should realize this, that it's really getting part of our lives here, like we are using internet more or less. I mean, it's for communication, observation of Earth, that it helps us getting better weather forecast, navigation. Who uses a map anymore and a compass? Do you even know how to use them? I mean, you just type in here we're going and haha, you go somewhere. How does it work? Well, it works with the help of satellites who send extremely precise time signals. That's how it works. And these time signals are also for free. So they are used for a lot of time synchronization in the systems, like banking and electrical power distributions. And of course, it's the research and the inspiration with space. Never underestimate that factor. So, but it's all the satellites out there, and the number of satellites are increasing exponentially. Every 2 years, the number of satellites has been doubled for the last 10 years, something. One of my astronaut colleagues actually pointed that out, and he called the Moore's law of satellites now. And they're huge, big like buses, and small like this. And yeah, it's a real size satellite. They're a 3D plastic copy of a student satellite building at KTH. That was a student at the time. He's now working for a space company. You can do so much up there. And when you start to combine all the data which are taken there with modern AI and machine learning algorithms, it gets very powerful. This is just for a kind of interesting thing. So a company, Maxar, has many observation satellites. They train the system to automatically find elephants on the steppes in Africa, and this kind of hopefully can help also maybe to counteract poachers and things like that. But it's also mainly just a fantasy who limits how much we can do with the data from space. The key, though, is the new launchers. So it becomes so much cheaper to send satellites to space because now there are reusable rockets which are cheap, thanks to SpaceX and Elon Musk. This thing over there, which is first stage coming back, they launch about 2 to 3 rockets per week now. This year they're aiming to almost 150 launches. And that has gotten the price down by a factor 10, but Elon Musk and SpaceX are not happy enough. That's up to the right, the Starship, which would get the price down with another order of magnitude, maybe even 2 orders of magnitude. And then it's opened up so many new possibilities what we can do in space, because the kind of bottleneck when it comes to price has mainly been the launch price. And new players are coming in, like Sweden. And by the way, even Norway. So both Sweden and Norway are developing launch sites up in the very far north. Here in Sweden, we have S-Range, where the infrastructure is ready to launch small rockets. But we don't have any rockets yet. That's a problem. Well, soon. Just want to mention that that's interesting enough. There's actually a Swedish startup company called Python Space. Must admit, I'm actually involved a bit in them. Tina and Tom Sjögren, explorers and also inventors, I would say, who are now developing their own rocket, which is the first start for future visions they have actually even going to Mars like Elon Musk has the vision. But that rocket would be perfect to have, and then they will be built. So there are facilities now outside Stockholm where they will build the first Swedish rocket. International Space Station, probably used until 2030. At least that's the plan. Then will be kind of brought down and burned up in the atmosphere. But then there will be other space stations. And I heard there was 7 companies who are working to kind of prepare for a new space station. But they do get some support from their space agents, I mean, it's US, the NASA, but not much. They have to put in their own money. And then they bet on that NASA, ESA, and others, plus a lot of private people, will use the space station. So that is the kind of future. They're becoming much more commercial, also human spaceflight. And here are some of the more kind of advanced ones. And these are not paper, PowerPoint stuff. They are building these now in their factories, and they say they might be able to send their first module up already next year, and they at least fully funded, they claim. Now, true, this is also part on kind of the story for Marcus Wandt, our second from Sweden who went to space. I also know that it was a Swedish-American lady, Jessica Meir, who flew 2019. But what I would say, Marcus and I, come from Sweden also. And so he flew with his company Axiom, which is a private company, with a goal to build a new space station. And in the meantime, sorry, it's misspelled, should be Axiom with an O there. They have a deal with NASA and with SpaceX that they can kind of sell journeys to the International Space Station for, not very cheap, but still. And here, Marcus Wandt had been selected as a ESA Spare astronaut in November 2022. And opportunity came up just a few months later. And Sweden, for once, was really on it, took it. And then he flew to ISS in January this year with a SpaceX capsule Crew Dragon to the International Space Station where he stayed, and that was a then deal with NASA. But he was also an ESA astronaut, so he was kind of twice an ESA astronaut. So it was a very kind of let's say, complicated setup, but it shows that more and more private actions are coming into the human spaceflight also. The goal then, though, is to fly to the moon. Now, well, that's the next goal, in addition to these things. But NASA has a program called Artemis. Artemis was a sister of Apollo in the Greek mythology. And with a goal to put the first woman and the first non-white human on the moon. I'm not putting a year there because that I don't really believe in. It was 24, then 25, and now 26, and let's say 28 maybe. But it's more than just what it was in the Apollo program. It was basically to put the American flag there by a human. It was a geopolitical game. It's still a geopolitical game, but it's much more than that this time. And it's to stay around the moon and have infrastructure there on the moon. And it's not only space agencies and government money. No, also here is a lot of private. Maybe you heard, there's been private landers going to the moon. So hopefully we will see within 4 years at least, next human on the moon. And it's not only an American-led program. I mean, East Sweden is part of that, but there's also a Chinese competing program, let's say. Chinese said they will land Chinese there in 2030. Artemis is also saying that it's explicitly preparing for going to the Mars. When? No time schedule set. if NASA doesn't get more money, it will not be in the 2030s via NASA. Might be 2030s via SpaceX. So SpaceX is developing its huge Starship to be able to send people to Mars. And you see down there left, that is the Starships. And a vision with a future colony on Mars, which is actually the vision this company and Elon Musk has. So trying to summarize, it's a lot of things happening in space. And more non-space company, non-space entity realize here is a new economy. Here is the future for economy. So 2 years ago, City Global came out and said, well, we believe the space economy will reach $1 billion in 2040. Well, just a month ago, or this month, McKinsey came and reported, said, oh, well, it'll be 1.8 trillion by 2038 already. This is, and it will, McKinsey expects the space economy to kind of grow about twice the speed as the GDP in general. And there's also new things. These reports, at least the city, which I read, they were also talking about mining astronauts. That will be something which will be done eventually, and learn and get them much money. And I think it was for someone at least of these bigger economy magazines to predict that the first dollar trillionaire will be the one who can start to do mine asteroids. Other possibilities, and this is where I'm doing some research now, more theoretical though, but it's that you could actually start to think of, if we cannot get down the temperature increase on Earth through taking care of getting down enough of the carbon dioxide we throws out, or actually the climate sensitivity is higher than maybe you think, well, you could think of putting kind of sunshades in space between the Earth and the Sun. And if you put enough, order of 0.5% to 1%, you can decrease the temperature on Earth with 1 centigrade, which might be enough, actually. That is not a completely new idea, but it's not been considered possible. But now with these new launchers, we get down the launch cost so much. I think it's not impossible. I believe it's cheaper than the cost in society if the temperature actually starts to go up for another degree. And if you want to have something really inspirational, look at this kind of vision talk by Jeff Bezos, the founder of the Blue Origin space company. He also has a company called Amazon. But that's kind of a very, which he kind of envisions, a city like that in space. So I guess I did talk for 14 minutes, but I don't mind to take questions until as long as you want.
Okay. We'll take questions here till about a little past 1:30 because we have to set up for the afternoon talks. But maybe start with Dr. Venter right here.
So I've talked to a lot of astronauts that get brain fog and feel they lower their IQ substantially, but it's not. Do you suffer that?
No, I don't notice that. I don't know if you heard the question. It was about that many astronauts feel stupid when they get to space. And that's something which kind of, we talk about, you get stupid when you get to space. If it's a new environment, if it's whatever, it's hard to say. But it's a completely new environment with the weightlessness, and you don't have references and all that. So I don't think anyone has done qualitative studies on that. Would be interesting.
Does it last, or does it gradually go away?
Well, I didn't really feel stupid, so I don't know. As I said, it would be interesting to do some research on that.
Okay. Do we have any other questions here? Bent, I know you have some questions about solar flight and... No? About using solar for improving flight? No? Oh, a question back there. Yeah.
Christer, I wondered, how was it feel to feel gravity for after having spaceless as just to feel gravity for the first time?
So when you come back, although my flight was only about 2 weeks, my flights, you feel very heavy. And one other kind of thing which happens is that your balance system, vestibular system, doesn't get its normal signals. So your balance system is untrained. So you kind of walk a bit wobbly for a couple of days. I mean, go slow away, of course, after a couple of days. And there are several effects, and those are much more severe the longer you've been up. And to recover, the medical doctors say, well, it takes 1 day on Earth for every day in space to fully recover. What I felt myself, and I see others, it feels like more than maybe half of that. But still, I mean, if you're up for 6 months, you need at least 3 months to recover.
That's my guess.
Okay, next question, please.
Hi, my name is Louise, and I'm studying biology here at Lund University. And I was wondering if you have any advice on how to get into the field of working with space or in space.
Well, continue with biology, and I don't know if you have some courses which can take you there, but I don't think you need to take particular courses here. I mean, look into the research which is done for biology related to space. ESA is doing some, and try to get connected that way. And if you even want to go to space, I mean, you could even that happen. I mean, Jessica Meir is a biologist in the background.
Thank you.
Okay.
Yeah, I'm wondering about physical effects as weightlessness has. So, for example, did you have the same thinking capability in space as on Earth?
Well, yeah, that was the question. I did not notice that I was kind of slower or something like that. I know that people have been kind of saying anecdotally that, well, you get so much more stupid in space. Maybe certainly it's a very new environment, and your brain needs to kind of, absorb all these new inputs and sort this out, which maybe takes some of your brain capacity away. But no, as I said, it would be really interesting to do some qualitative studies on that. I mean, I'm sure you could do that. Set up an IQ test and you do it regularly over time and see if it's a difference.
Yeah.
Thank you. You can go next.
Yes. So if you like mathematics and physics, and I go to high school right now, and I would like to study like something with space in the future, which university program will give me a good opportunity in the future, do you think?
Well, I'm biased, of course, because I'm a teacher and professor at KTH, where we do have, I think, a very good master program, aerospace. If you want to study space-related things earlier on, I mean, Lund Technical University, they do have a engineering program, even on the bachelor level for space engineering. But if you in the future I want to work with space, you don't have to take these things. I mean, there were any kind of engineers is of interest in the future space industry. I mean, we need electricians, we need, hackers. We need people who can design mechanical things, everything. I mean, that's what I'm trying to say, that space is becoming part of everything.
Thank you.
Thank you. Next question, please. Oh, there's a question first with the mic over there.
Professor, I was thinking about the ever-growing problem of the space waste, and if you maybe have some insights on how we could fix this problem. Thank you.
Did you say spacers or space debris?
The space debris.
The space debris. So it's true. More and more stuff kind of gets in orbit, and there is a concern that eventually reach a point which is called the Kessler syndrome, that there's so many that you exponentially start to... They collide so often that it just kind of increases exponentially. And the way to... First of all, it's good because everyone started to discuss this. And the first point we need to do is to have better regulations and agreements on how we put things there and how we can allow to put stuff there to make sure we don't put more there. For example, it used to be that if you put something there, it should be gone 25 years after it's not used anymore. Well, that's been now kind of said, okay, no, 5 years maximum. Maybe it should be even shorter. But it's not a law, so to say. I mean, it's not so easy to get agreements between all the countries when it comes to this. It should go UN, but that goes very slowly. And some countries, say, read China and Russia, they don't really want to agree with what West wants. The other thing is technical, that we should develop methods to take away at least some of the bigger parts. Because if the bigger parts collide, they create so many. There are experimental missions which will soon be launched to start to develop these kind of methods.
Okay, thank you. You're next.
Okay, hello. Lagrange points are obviously very important, and there are so few of them, 5 to be specific. And I'm wondering what you think the future for Lagrange points are. Like, do you think they will be like space hubs or like pit stops, or do you think there will be conflicts between nations over Lagrange points, or how do you think that will develop in the future when, like, the importance of them really becomes clear?
I do think there will be many want to put things there, so there will be some kind of hubs. But space is big, so you kind of have to. You can probably have many there if you have to agree to some extent how to kind of. But that's really what we're already doing now around Earth. That if someone has put a satellite in a certain orbit, you cannot put something there on the same orbit. There's some agreements. But I think that this risk of confrontation could rather come earlier on the moon. I just heard, I was very surprised when I heard it, I see if it's correct, or that if you put something on the moon, basically you can claim that, okay, everything around 50 kilometers around me, radius, you cannot put anything there because then you disturb me here. So now I claim this area.
So you think there will be a race for nations going around putting down a flag and claiming 50 kilometers?
To some extent, yes.
Okay.
And to some extent, yes.
What points of the moon do you think will be most contested?
Well, it will be the South Pole, because the South Pole has a very good location, and it's a kind of particular one. I mean, you can have sunlight all the time on crater rims, so you have solar rays and electricity all the time, and it seems like there's more water available. So therefore, many want to go there. Then, of course, if someone find a mine somewhere, or some, a very, very valuable resource somewhere on the moon, then but then you probably are there, and you say, this is mine. I don't know.
Yeah, okay. Thank you.
Next question over there.
Hello, Professor Fuglesang. It's nice to see you in real life. My name is Niels. I'm a PhD in biochemistry. But my question was, if I understand correctly, from the picture with the 44 astronauts waiting to be sent up, would you say that it's, is it not coincidence, but if you really fight for becoming an astronaut, being sent up there, is that a viable route, or is it more just coincidences that you then took with both arms, and then did the stars align for you to be sent up? Was it a chance event, or was it something you really can consciously steer?
So the needle side, that is to be selected as astronaut, to start to train as an astronaut. And once you've been selected, then you can be pretty sure. Not everybody, but almost everybody gets to space sooner or later. It's just a waiting. But to be selected, yeah, there's a lot of the luck factor in there, for sure. I mean, you have to have the right background and all these things, but then, as you said, the stars has to align. You have to be the kind of right person at the right time, at the right place. For example, at the time, Sweden in '92 actually did pay decent amount of money to ESA. Very coincidentally, maybe, but 6 astronauts were selected at that time in '92, and those are exactly the 6 countries would pay most to ESA in relation to the populations. If that's a coincidence, I don't know. But and then Sweden stopped paying to the human space program, and things became a little bit harder for me.
Thank you.
Okay. One more question. Could you pass the mic there?
I'm sure the experiment's been done, but is it possible to get pregnant in space? And has anybody done it?
I don't think that experiment has been done, not even on animals yet. But I know there are discussions of doing some, what do you call it, fertilization of some even mammals, maybe, or maybe frogs, some animals in space to start to understand what will happen. But humans will be a long time before it happens, I believe.
Okay. Do we have any other questions? All right, then what I'm going to do is we'll go outside with Professor Fuglesang, and let's please say thank you for a wonderful presentation.
Well, thank you. Thanks for having me.